Math Morning, Mr. Dirk is back at it again. Today we'll be doing operations with square root.
All right, so operations with square roots. Operations, we're talking about adding, subtracting, multiplying, dividing. Let's start with adding and subtracting. So when you're adding and subtracting radicals or square roots, it's kind of just like adding and subtracting like terms, right? See right here, combine like terms. A little refresher, if I have 2x plus 3x, what does that equal? Well, they are like terms because they both have just an x. So 2 plus 3, that's going to be 5x. You guys remember that? I think so. If I have 2x plus 3y, these are not like terms, so I cannot combine them. So it stays just like that. When we're doing radicals or square roots, you can do it just like this if the number underneath the radical sign is the same, right? So I'm looking at this one. Yeah, these are the same, right? There's a 7 under the radical and there's a 7 under the radical. So this, if I said 3x plus 2x, what does that equal? Well, that's really 5x, right? So if I add these up, this can really be 5 a radical 7. A boom, just like that. Piece of cake. But sometimes we're going to throw you a curveball, right? Square root of 3 and square root of 48 is not the same number under the radical, but sometimes you can simplify one of the numbers, right? So 48, I'm going to try to simplify that. If you remember, write down this number line. Pretty please, write it down. So I'm writing down all of the perfect squares. 36, 49, 64, 81, and then 100 is below that. So what do? All right, 48, that's between 36 and 49. So I start going down. Can 36 be divided into 48? No. What about 25? No. What about 16? Ding, 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 ding. Yes, it can. So this can be rewritten as, instead of square root 48, square root 16 times, well, 16 times 3 is 48. So radical 3. So we have radical 3 minus radical 16 times radical 3. And this can be simplified. A square root of 16 is 4. So it's radical 3 minus 4 radical 3. All right, we got the like terms. They both have radical 3. This is, there's an imaginary 1 right there. So if I was using x's, I would say 1x minus 4x. Well, that equals negative 3x. So this will be negative 3 radical 3. Ba-boom, bam, pow, done. All right, over here, number 3. If I'm looking at this one, well, which ones have the like radicals? This is radical 2, that's radical 3, and that's radical 2. Well, I can't do anything with this radical 3, so it's going to stay there. So I can combine the radical 2's. So I'll put a 1, imaginary 1 in front of that one. And now I have 4 radical 2 minus 1 radical 2. Well, 4 minus 1 is 3 radical 2. And then I have to keep this plus 3. So plus radical 3. And that's it. And I cannot combine these anymore because they are not like terms. Ooh, this one you got to do twice. You got to simplify 2 times. So I'm looking at 90. All right, 90. I guess I got to do one more. 100. So 90 is between 81 and 100. Which of these numbers can go into 90? 81, nope. 64, no, nope, 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 nope. Okay, 9 can do it. So I can do radical 9 times radical 10 minus, what about 40? You might want to say, oh, 8 times 5 is 40. Well, those aren't perfect squares, so that's not going to help you. 40, we'll start there. What number goes into 40? Well, how about 4? Yeah, 4. 4 times 10 is 40. So radical 4 times radical 10. All right, they both have radical 10. Good. This simplifies to 3 radical 10, minus 2, radical 10. Then 3 minus 2 is just 1 radical 10. And if you have 1 radical 10, that's the same as just radical 10. There we go. Moving on. Radical cat. Alright, now we're multiplying and dividing radicals. Let me break this down for you. So you have two different numbers here. You're going to multiply the coefficient times the coefficient, and then the radical by the radical. And that's it. Simple as that. So you do 2 times negative 4. That's a negative 8. And then you do radical 2 times radical 6. 2 times 6 is 12, so you write radical 12. Is that it? Not yet. You have to simplify the square root. So, right, you can write this, the old number line again. We got 0, 1, 4, 9, 16, 25. So, radical 12, that's between 9 and 16. And the biggest factor is 4. So, I'm going to write negative 8, radical 4. And then 4 times 3 is 12. So, radical 3. And then this simplifies the radical 4, that's 2, so it's negative 8 times 2, a radical 3. And then negative 8 times 2, you multiply those together, you get negative 16, a radical of 3. Bam, just like that. So you multiply the coefficient times the coefficient, radical times radical, and simplify if possible. It's not always possible, but if it is, you do it. Over here, this is the distributive property, so you got to do the number on the outside by both of the terms on the inside. So here we go. I'm going to do coefficient times coefficient. 4 times 3, 12. Now radical times radical. Radical 7 times radical 2, radical 14. So that's my first term. And then I do 4. This is a negative 2, right? So that'll be negative 8. And there's no radical next to the 2, so I just keep this radical 7. It's really radical 1, which just equals 1. So technically it could be there, but you just put it at the end. Radical 7. There we go. So now you check. Can we simplify these? 14. Alright, that's between 9 and 16. Can you divide 9? Nope, nope. And the 0 and the 1, those don't really matter. So this can't be simplified. 7, that's a prime number. So this one, you can't simplify, and that's the answer right there. Some people might try to do, well, can I do 12 minus 8? No, you can't do that because they're not like terms. And you can't subtract the radicals because this is radical 14 and radical 7. So you can't simplify it. That's your answer right there. Alright, the quotient property. This is talking about division. These are all going to work out to nice fractions because every number inside of these radicals are perfect squares. So this first one, this can be written as radical 16 divided by radical 49. The quotient property says you can break this down into its own fraction. And the radical 16, well, that's 4. Radical 49, that is 7. That's it. Ba-bam. Over here, right, same thing. On the top, we'll do radical 121. On the bottom, radical 25. Square root 21, that equals 11. Square root of 25 equals 5. So our answer is 11/5. Done. So now we're going to move on to something called rationalizing the denominator. That is an awesome name, denominator. I'm going to change my name to Mr. Denominator. So that is the bottom part of the fraction. You can see in these examples, there's a radical in the bottom. Mathematicians, we don't like that. We want to keep it on the top in the numerator. The reason for that, if you have, this is a irrational number, it goes on forever and ever and ever and ever. And you really can't divide by that. You can divide into it, so it's okay if it's on the top. But as a rule, we want it to be on the top. So that's what we're going to do right now. What we can do if you have this and you multiply it by 1, it's going to stay the same. So I can multiply it by the square root of 11 times the square root of 11, right? This part equals 1, so I'm not changing the value. But why would you do that? Right? Did you say that, or was that me? I don't know. So the reason you do this is because it's going to rationalize the denominator. It will make it a rational number on the bottom. So let's just see what happens. The top 3 times square root 11 is 3 square root 11. And the bottom, square root 11 times square root 11, well, that's square root 121. And if I simplify it, right, the top stays like that. And the bottom is a perfect square. The square root of 121, oh, that's 11. You can always check and see, okay, can I simplify the coefficient on the top and the number on the bottom? In this case, you can't. So that is your answer. It is rationalized. And this step right here, I wrote square root of 121. You don't have to do that. You can just know square root of 11 times square root of 11. Well, that equals 11. All right, there's the shortcut. This next one over here, you're not going to like this. You might figure it out right now, but you're not going to like it. You're going to get mad at me, but that's okay. So what I want to do, the same thing. I multiply by a radical, instead of 11, radical 4 times a radical 4. This part equals 1, so I'm not changing the value. 1 times radical 4, well, that equals a radical 4. The bottom, radical 4 times radical 4, well, that's radical 16. All right, what does it simplify to? Radical 4, that equals 2. Radical 16, that equals 4. And this simplifies to 1/2. All right, so that is your final answer. But there's a shortcut. If you look at this first part, right, 1 over a radical 4, you know this equals 2 on the bottom, right? Radical 4 equals 2. So I can just say 1 divided by 2. Bam. So if you look at it, you can just, if the bottom's a perfect square, just change it. Don't do all the steps. Do it that way. It's much easier. All right. Moving on. All right. So now we're going to use the quotient property and then rationalize the denominator. My brain exploded. All right. Let's go. So this one, this equals a radical 8 divided by a radical 5. Ooh, my bad. Equals a radical 8 divided by a radical 5. You can simplify the radical 8 right now, but you can wait till the end. That's what I'm going to do. I multiply this by a radical 5 divided by a radical 5. This equals 1, and you choose the number that's in the denominator, that's on the bottom of the fraction. When you simplify it, radical 8 times radical 5 is a radical of 40. And on the bottom, radical 5 times radical 5 is radical 25. Right? And the square root of 25 equals 5. So the bottom is just a 5. Okay? Now we need to simplify the numerator, the number on the top. So you can write your number line. We've got 0, 1, 4, 9, 16, 25, 36, 49. So this 40 is between 36 and 49. Can 36 go in the 40? Nope. 25? Nope. 16? Nope. 9? Nope. 4? Yep. So this equals radical 4 times, well, 4 times 10 is 40, times radical 10 divided by 5. And this simplifies, I'll do a little arrow. This square root of 4 is 2. And then we have radical 10 divided by 5. That is your final answer. You might think, well, hey, can I do this 10 divided by 5 and simplify it? No, you can't, because this is under a radical sign. This is not. And the 2 and the 5, you can't simplify that. So you just leave it like it is. All right, over here. This will be radical 12 divided by a radical 6. All right. You can simplify the top now, but I'm just going to wait. We multiply it by a radical 6 divided by a radical 6. And the top becomes 12 times 6, that's 72. So radical 72 divided by the bottom. Radical 6 times radical 6 is a radical 36. And the square root of 36 is just 6. So this number line, where does that fall in? Well, after 49 is 64, and then 81. All right, which can go in the 72? 36. That can be divided by 72, or into 72. So this becomes radical 36, and 36 times 2 is 72. So times radical 2 divided by 6. Square root of 36 is 6 radical 2 over 6. Oh, look, the 6 and the 6, those two cancel, right? Cancel. So you're left with a radical 2. And that is it. That's the answer. But you might be thinking, well, hey, I'm looking at this. Can't I just do 12 divided by 6? You can, right? 12 divided by 6, that's 2. So you could just, at the beginning, radical 2. So what I'm trying to show you is, if you can simplify at the beginning, do it, because it'll save you a lot of work. If you don't, you will still get the same answer. But always look at the beginning and say, okay, is there an easier way to do it? If there is, go ahead and do it. You've been doing a good job with this video. So now watch a fruit bat eating a grape.
Look at those cheeks.
No more bat. Now time to bring the pain. Alright, we've got two tough ones here. Just gotta follow the rules you know, and we can do it. So, this first one, we're adding and subtracting. Look at the first term. Can I simplify that? Nope, it's going to be the same. So that's 3 radical 7. The second term, minus 2 radical 28. Well, can I do that? Yeah, do your number line, right? We got 0, 1, 4, 9, 16, 25, 36. Okay, that's between there. What can go into 28? 25, nope. 16, nope. 9, nope. 4, yes. So 4 times 7 is 28. So this can be minus 2 times radical 4 times a radical 7. Alright, just like that. Now, we're going to add square root 63. Can we simplify that? I don't know. Let's check. Let's extend this. 49, 64. Alright, can that go in? Nope. 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 How about 9? 9 divided by 63, yep, it's 7. So it becomes radical 9 times a radical 7. Ooh, okay. I hope you see what's happening right now. So now when I simplify, 3 radical 7 minus 2. The radical 4, that becomes, the square root of 4 is 2. Alright, a radical 7 plus square root of 9 is 3 radical 7. Alright, let me just simplify this 2 and the 2, right? So 3 radical 7, negative 2 times 2 is minus 4 radical 7 plus 3 radical 7. So now we need to add and subtract. This might seem like days ago. It was only 20 minutes ago. They all have the same radical, so my answer will have a square root of 7 at the end. So I have 3 minus 4 plus 3. Well, 3 minus 4 is negative 1. Negative 1 plus 3 is 2. So my answer is 2 radical 7. Alright, this one over here. Let me change my color. When you have something that's squared, right, you just write it by itself as this multiplied by this. So if I write the whole thing down, it's going to be 3 radical 3 minus 2 radical 2 times the 3 radical 3 minus 2 radical 2. So this is the same as it is on the top. So when I do this, I'm double distributing, or you might know FOIL, the first times the first, outer times the outer, inner times the inner, and the last times the last. So I'm multiplying every term by every term. So let me do the first one. Radical 3 times 3 radical 3 times 3 radical 3. So that's the first part. 3 times 3 is 9. Radical 3 times radical 3 is radical 9. That was the first one. Let me do the outer ones. So 3 radical 3 times negative 2 radical 2. Well, 3 times negative 2 is negative 6. Radical 3 times radical 2 is radical 6. Alright, let me do the inside ones. 2 radical 2, or negative 2 radical 2 times 3 radical 3. Negative 2 times 3 is negative 6. Radical 2 times radical 3 is radical 6. And now I'll do the last ones. Negative 2 times negative 2 is a plus 4. Radical 2 times radical 2 is a radical 4. There we go. So when I simplify, 9 square root 9, that becomes 9 times 3. Okay. I can't simplify those at all, so I'm just gonna, well, can I actually combine them? They both have the same square root, so I can. Negative 6 times negative 6 is minus 12, and then I keep the radical 6. Oh, I can. Okay, good. Then over here, this will be 4. The square root of 4 is 2, so it's 4 times 2. Okay, so now I just got to multiply. 9 times 3, 27, minus 12 radical 6 plus 8. Right? 4 times 2 is 8. And now I can do 27 plus 8. What's that? 35. And I have minus 12 radical 6. And that's it. Whew! We did it. So these next ones, I want you to try them on your own. All right, give these two a shot. All right, try these. You try them? Try them. And these are my favorite potato chips. Try some brand. I think these are a Massachusetts thing. They are delicious. All right, let's look at this first one. So, what did we do? 2 square root 5, kept it the same. Square root 12, ooh, we simplified. We did 2 radical 3, because the square root of 12, that can be the square root of 3 times the square root of 4. And that simplifies to 2 radical 3. And the radical 27, that can be radical 9 times radical 3. And the square root of 9 is a 3, so simplifies to that. And then we've got a 2 radical 3 minus 3 radical 3. 2 minus 3 is negative 1. And that's why you're left with minus 1. It's not really there, but it is minus 1 radical 3. Alright, this next one. We did W distributing, right? The FOIL method, or this time I did this first term, I drew the lines, okay, times the first term over here, and then times the second one, and then I took this one, I did times the first, and then I did times the second. So, 4 radical 5 times 4 radical 5, that simplifies to 16 times 5. Because radical 5 times radical 5 is radical 25, which is 5. And then we did 4 times 3 is 12. Radical 5 times radical 2 is radical 10. And then we did this second term times the first one. 3 times 4, 12 is minus, so it's minus. Radical 2, radical 5, radical 10. And then we did negative 3 radical 2 times negative 3 radical 2. Negative 3 times negative 3 is 9. Radical 2 times radical 2 is 2. And the reason for that is radical 4 equals 2. Okay? Then we did some multiplying. Okay, and then we just simplified. 80 plus 18 is 98. So that's it. That's the whole video. I mean, 2 lessons in 1 unit, that's amazing. So you're done with that. Good luck on this mastery check. Good luck with the packet. You got this. One more chapter after this. Durkis out.
Look at those cheeks.